Do this. What is up with the story about Newton's apple? So the story is Isaac Newton sitting in an orchard, an apple falls, hits him on the head, and he's like, oh snap, gravity. But it's actually more complicated than that, surprisingly. So what's actually more likely is Isaac Newton is thinking about gravity. And as he's thinking about gravity, he comes up with this idea that the reason why apples fall and the reason why the moon goes around the earth are the same thing, gravity. And that is a crazy, crazy, crazy connection to make. No one had made anything close to that. And turns out he's actually right. It is the same force that pulls apples down, that pulls the moon around the earth. And so that's the idea. So, decided the force that pulls apples down which is gravity, also causes the moon to orbit Earth. There's not very many scientific discoveries that kind of blow everyone's mind and change everything about science, but this is one of them. Understanding this idea of what gravity did was a huge, huge, huge change, and really important for where we were going. So what is gravity really? We haven't defined gravity yet. We said that the acceleration of gravity is the rate at which things fall. Okay? We said that the force of gravity was weight, but we didn't actually say like what it actually is. And Newton was the first one to kind of define it. And he defined it as an attractive force between objects with mass. Attractive force between objects with mass. So, here is a statement you didn't think I would say today. You are literally attracted to every person in this room. That's right. And not only that, the person you're sitting next to is the person you're attracted to most. Okay? So there you go. Learn something new every day. He asked if he could sit right here. So, you're attracted to everyone in this room. And here's why. Gravity is an attractive force between objects with mass. You have mass, the person next to you has mass, you're attracted to the person with mass because they have mass. That's what gravity is. Now, this is not a perfect definition because this doesn't explain why that happens, right? And not only that, Newton couldn't actually do that. Newton couldn't explain why gravity happens. It wasn't until Einstein that we figured that out. So 150 years later that we actually figured out why gravity existed. He just knew what it was. It was an attractive force between objects with mass. Okay? So, what is Newton's law of universal gravitation? So let's define it first. So it basically, so the force of gravity is directly proportional to the object's mass and inversely proportional to the distance between them. So the force of gravity is directly proportional to the mass. So the more mass, the more gravity. and inversely proportional to the distance. So the further away they are, the less gravity there is. So if you're wondering, if there's an attractive force between me and the person next to me, why is that force not big enough to actually squish me to them? The reason is the force is not very big because the masses are not very big and the distance between them is relatively large. So that's why you're not getting squished to the person next to you. It's why, I reach out and I can't Luke Skywalker things. Okay, I can't just force pull things to me because the distance is too large and the masses is not big enough.
Isn't the moon like pulling away from the Earth?
Correct.
So why is it pulling away?
Its tangential velocity is slightly too big. So it has slightly too big of an inertia, which is pulling it away. It's like 1 centimeter a year. So it's not even like it's very much. It's barely anything. All right, here's the equation. Fg equals big G, not to be confused with little g, m1, m2 over d squared. You're familiar with all those symbols except for big G, which is the universal gravitational constant. And the universal gravitational constant is a measure of gravity's general strength as a force. So it's how strong in general is gravity. So for example, if I want to know how strong in general is electricity, there's an electric constant or magnetism. There's a constant that tells me how strong it is. Okay? And it, as a force, it's relatively strong. Gravity has one of these too. And its value is 6.67 times 10 to the negative 11th. That number is so small that if you took 1 divided by 1 billion, that would still be about 100 times too big. Okay? We're talking about a ridiculously small value. So, Mr. B, what you're saying is that gravity is the wimpiest of all forces. And that's exactly what I'm saying. Gravity is the wimpiest of all forces. Okay? And here's how you know. When you were an infant and you're laying on the table and you're screaming and caterwauling and all that good stuff, you're breaking gravity because you're throwing your arms around, you're kicking your legs, and you're screaming and all that kind of stuff. If an infant can best gravity, it can't be that large of a force. Okay? Infants cannot break magnets apart. They're not strong enough. And the force of magnetism is too large. So gravity cannot be very big. And it isn't. It isn't very big. Now you're saying to yourself, but Mr. B, gravity is big. It keeps me on Earth. Okay. Why is that? Because the mass of the Earth, m1, is huge. And so if something is ludicrously big, you can get a force of gravity that's large enough to notice. But you have to have a force of gravity that's really large. All right. Questions on 1 through 4?